So welcome back. Today we learn about a very basic principle of physics which is used in many circumstances, in many situations. It's known as the principle of superposition. Here we'll deal with the principle of superposition of waves. Okay. And we take up what we call pulses. A single this thing, and what we create is the disturbance is pulses, and we are taking a stretched string. Okay, I'm not saying as to how the pulses will move in two opposite directions. Okay, that there will be occasion which I can tell you, and I'll tell you. Well, if this pulse goes and is reflected back without a loss of energy, then the reflection back will be like this. So there is a pulse. There is a pulse. Shape is like this. Okay. There is another pulse whose shape is like this. So this is kind of convex. We look from above, and this is kind of concave. Okay. And they are advancing. They are moving. They are traveling. They are propagating in opposite directions. In the same string, stretched to the same tension and having a uniform mass, so that the mass per unit length is also the same, meaning thereby that the velocity is the same. Okay, we are taking a very favorable situation, same amplitude, same velocity, same this, same that. Okay. Now this wave would travel like this, and this wave will travel like this. What happens? At a certain time, which I say t is equal to 0 seconds, this is the kind of situation which I have shown to you is chematically. Then they come close to each other, just adjacent to each other, and the situation becomes like this. Now thereafter what happens? In this region which is shown as the dotted line, this one and this one, they overlap. Okay, so let me make for you the pulse which was coming from the left to right, and the pulse which is coming from right to left. Okay. They will not appear over here. But instead what we find that they have vanished. They are not there. Out of the thin air, they vanish. And what we obtain here is a simple line, and the two disturbances, the two pulses, they disappear. They overlap. But they, after that time, now this one emerges over here and this one emerges over here, and they will say, well, we have met each other, how are you, this, that, etc., etc. They vanish. And after that they say, bye bye, tata, I go my way. Okay, home, they go to their destinations, which has been shown over here, that my way and my way, your way and my way. Okay, so this is what is called in the Quranic injunction, the beautiful thing, lakum dinakim walayya deen. For you your deen, and for me my deen. So they vanish. They go ahead after they meet each other. Well, when pulses overlap, the resultant disturbance is the resultant disturbance due to each of them is the algebraic sum. What is the algebraic sum? like if you just want to know 3 plus 2, 3 plus 2 is equal to 5, and minus 3 plus 2 is equal to minus 1, okay, like that. So with the signs, the algebraic sum is the key word in the explanation of the principle of superposition, okay, in any situation. Is the algebraic sum of the disturbances due to each pulse, okay, and therefore they will vanish momentarily for some time. And of course I have not shown you as to what happens when they are advancing little by little, then very interesting shape of the pulses will appear. How much they vanish, how much they not, that you can do it with the help of a pencil on a paper and see for yourself and enjoy as to what is happening. Now, another point is that each pulse moves as if others are not present. That means independently of each other. Hey, 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 I move, I go on my way. Okay. Each pulse moves as if others are not present. But what happens to the medium? The constituents of the medium suffer displacement due to both, or in general for all of the pulses which are there. So the total disturbance is the algebraic sum total of all the disturbances caused by the various pulses. In the case of these two pulses, I can write, if the first pulse is represented as y1 x comma t and the other y2 x comma t, then the resultant disturbance will be y x comma t is equal to y1 x comma t plus y2 x comma t. Okay. Now I can write that what we have learned, kx minus omega t, this is usually what we write. If I divide it by k, I get x minus omega upon kt, which I can write as x minus 2 pi upon capital T upon 2 pi over lambda to t is equal to x minus lambda over t, and it turns out to be equal to x minus vt, where v is the velocity in that medium. This is true for waves longitudinal or transverse, sound, or light waves, in electrical disturbances. Everywhere this principle is used. Okay. So when the time comes, I'll just refer of the superposition principle, and I insist that you understand superposition principle now. Okay. So I can write, if there are so many of them, these disturbances are present together. y1 is equal to function 1, y2 is equal to function 2, yn is equal to function n of x minus vt. So on superposition I can write that the net result y is equal to f1, f2, fn of x minus vt, which by what we have, briefly I can write it as summation of this thing. Okay. So therefore now we understand that superposition principle, the beauty of thing, this is called living together. This is called living together. You live and the other one is also living, even if that's an enemy. So this is the way the Almighty feeds all of us, is Rabbul Almin to the pious ones and also the naughty ones. Okay, He feeds every one of them. Rabb means the feeder. Rabb means the provider of energy, and that is how live and let live principle works in the case of superposition principle. Also in the case of in the case of what we call a tug of war. The tug of war means that if you are stronger, you can carry us on to your side. If we are stronger, we will carry. And if we are equal, then nothing will happen. So we take specific examples now and solve the problem. Let us take two harmonic waves acting to each other, similar to each other in very many aspects, okay, which are transverse and they are on strings, okay, traveling waves, so that omega, k, nu, lambda, v, a and capital T, they are capital T also we can take along, okay, so these things are similar. Now mathematically we define these two harmonic waves as y1 and y2 respectively. y1 x comma d is equal to a this, and y2 is a this, where an additional phi is there. That means this y2 leads y1 by phi if it is positive, and it lags behind this one if it is negative. So this thing you are very well versed in now by this time. So I can write it as y x comma t is equal to a sine of omega t kx minus omega t plus a sine of kx minus omega t plus phi, which a taking out as a common factor will get a sine of this plus sine of this. Okay. Now I have a trigonometric identity, sine of a plus b plus sine of a minus b, okay, which I can write sine a cos b plus cos a sine b plus, for this one, sine a cos b minus cos a sine b. When they add together, then this part goes. Okay, so I am left with 2 sine a cos b, wherein we can say that a is equal to a plus b plus a minus b divided by 2, and b is equal to a plus b minus a minus b, whole thing is divided by 2. So if you think about this identity, spend a couple of minutes, even the bio students without mathematics as a backup, then we write this according to this: 2 sine a plus b by 2, okay, sine this plus this divided by 2, and then cos of this minus this divided by 2. Okay, so you can say that this turns out to be minus 5, but cosine is always a symmetric function, so cos of minus 5 by 2 is also equal to cos of 5 by 2. Right? So now let us put together 2a cos of 5 by 2 and sine of kx minus omega t plus 5 by 2. So this is a new equation that we get for y is equal to x comma t. So look at it. It has an amplitude 2a cos of 5 by 2 and sine of kx minus omega t plus 5 by 2, which is definitely a harmonic travelling wave in the positive x direction. Okay. whose amplitude is 2a cos of phi by 2. Okay. Now I am just taking one case where phi is equal to 0. Initially this phi is taken as equal to 0. So the two equations are one and same. Okay. So then what happens is that we can say that because there is no phase difference, therefore y1 and y2 are in phase. And if so, then what we get is this equation. Yx comma t is equal to 2a sine of omega t minus kx. It's just like this. This is there. We add these two together. This a plus a becomes equal to 2a, and retained is sine of kx minus omega t. So that means the explanation of this wave here. This is the wave equation. Okay. This is the equation that we should look at. Okay, this equation. Now we can take phi is equal to pi, and let's see what happens. So in my mathematical analysis, I obtained the value of the total disturbance yxt as a function of y1 and y2, and that was 2a cos of phi by 2 sine of kx minus omega t plus phi by 2. Okay, and I saw the case. We discussed the case when phi is equal to 0. So this quantity becomes equal to 2a because cos of 0 is equal to 1. Also, if this quantity is 2 pi, then also the value turns out to be equal to 1. Okay, but and if I plot this, wherein I have shown as these two waves, one you can see and the other wave I just try to impose upon this, superimpose on this, superpose on this, and they are meeting in the same phase. Then what happens is that we obtain a new wave with twice the amplitude of their constituent waves. Okay, and this is called constructive interference. In light and in electromagnetic radiations, we talk about constructive interference. The same set of mathematics is done there also, and we obtain the condition of constructive interference as to when the constructive interference is obtained. So I told you in the value of cos of phi is equal by 2 is equal to 1, which is 0, 4 pi, okay, phi is equal to like this, 8 pi, etc. Okay, that we obtain constructive interference. Their corresponding lambda values can also be written because 2 pi is equivalent to lambda. Then this is 2 lambda, 4 lambda, like that. Okay. Now, if I take phi is equal to pi, that means the two waves y1 and y2, they are opposite to each other, in complete opposition to each other, which is also said that they are out of phase with each other. Then cos of phi by 2 becomes equal to 0. And then what happens is that the net result, net value yx comma t is equal to 0. This is what is shown over here. I have one of the waves is like this, and the other wave also of the same amplitude is having a phase difference of 180 degrees at all positions of x. When these superpose on each other, then for anywhere, this and this become equal to 0. This and this become equal to 0. This and this become equal to 0. And therefore what we get is that after this destruction has taken place, in which the two waves destroy each other, we get a straight line with x. Okay, so this is called destructive interference. Next, in the next lecture, and next to next and next to next, We'll talk about the deflection of waves. Okay, when the interference, there is an interaction at rarer to denser medium and denser to rarer medium. Remember these terms from high school. Standing waves, which are not waves at all, with nodes and antinodes. Normal modes of vibrations. Harmonics, and in sound we also call it, in music we call that. Harmonics are the frequencies, associated frequencies, nu, 2 nu, 3 nu, etc. Okay? They are called harmonics. But overtones, in the case of music, we call the fundamental frequency, and the first overtone is the second harmonic. Okay, we'll learn about that. We'll also talk about the phenomenon of resonance, and then the beautiful phenomenon of beats. Okay, where we have experiments with the tuning fork, etc. And the beats is a very interesting subject, and particularly from the point of view of the examinations, 1 out of 4 or 1 out of 3 or 1 out of 5, and that is known as the objective questions. Okay. Then we have even a very interesting effect called Dopplers effect, where the frequency changes. There is a real frequency and there is an apparent frequency. We'll talk about that. And then when we take it to optics and we talk in terms of galaxies, etc., then there are shifts which are called blue and red. Okay, blue and red. I'll tell you about that in the context of video red. So I hope these are the promises that we cover in 3 lectures or 4 lectures, I don't know. Okay, the lectures I'm putting short. I have enjoyed. So this is our lecture number 101, and hope we finish it, the course for class 11th within maybe another 3-4 lectures, 104 lectures, 105 lectures. So thank you very much being with me. Have enjoyed.